Hello students, welcome back to my channel once again. So today we will be covering the chapter probability from CBSE board grade 10. So we will do the detailed explanation of the chapter first, and also we will solve some problems of it, and we will understand each and every topic with animated diagram. Okay. So the first topic of the probability is introduction to probability. So first we will understand what probability means. Okay, so let us understand different terminology before we start with the probability. So, what is random experiment? So, it is an experiment in which all the possible results are known in advance, but they cannot be predicted with certainty. So, what that means? That okay, so if whenever we are doing any experiment, we know what can be the possible outcomes or results, but out of those results, which we can't predict, maybe if I am asking you that, okay, today whether it will rain or not. So the answer, what are the possible answers? Okay, yes, it could rain, or there will be no rain. So that means yes or no. So now whether it will be yes, that cannot be also predicted with certainty, or whether it is no, that is also not predicted with certainty. So probability where we will use the random experiment where the what will be the output. We know the different values of output or results, but that cannot be predicted with certainty. Then that is called the random experiment. Like let's take an example of rolling a die. So whenever we roll a die, so there are six numbers in it: 1, 2, 3, 4, 5, and 6. Now, can you tell, like, whenever you are rolling the die, can you tell that, okay, which number will come? With certainty, we can't tell. We know that any number between 1 to 6 will come. It will not happen that, okay, 7 will come. It is not possible for a particular die whenever we are rolling, right? But we know that from 1 to 6 will come, but we can't tell with certainty which number will come. So it may happen that 1 will come, then it may happen that 2 will come, 3 may also come, 4 or 5 or 6. Any number between 1 to 6 can come. So these are the called the possible results or outcome. Now we will learn into the what do you mean by the outcome. So outcome means I already explained that is the result of a random experiment, right? So that is called the outcome. Now, in this case, what are the total possible outcomes? So, the number of all possible outcomes for rolling a dice will be 6. So, here we assume that each outcome is likely to occur equally as other. So, that means equally to other means there out of these 6 numbers, there are equal that 1 can also come, 2 can also come, 3 can also come, 4, 5, or 6. So each number coming whenever we are rolling the dice, any of the number can come. So each of outcome is likely to occur, right? So that is why it is called equally likely to occur. Hence, 1, 2, 3, 4, 5, these are called equally likely outcomes. So, any one number can come from this. So, we can't say that, okay, in this case, 5 will not come. No, 5 can also come. So, there is equal chances of any number between 1 to 6 can come. So, that's why it is called equally likely outcomes. Now, the next topic that we are going to learn, that is the all possible outcomes of tossing coin experiment. So we know that in a coin we have head or tail, right? So whenever a coin is tossed, so this is the head part and this is the tail part. This is we are considering 1 rupee coin. So 1 rupee coin if we tossed, then this is the head and this is the tail part. Now all the possible outcomes are, so whenever you are tossing the coin, so it may happen that head may come or tail may come. So what are the possible outcomes? That head or tail. So the number of all possible outcomes will be 2 over here. Now, when two coins are tossed together, then what will happen? So let us take a look. So now, when two coins are tossed, so what could be the result of the first coin? So the first coin result can be head, and what are the option for the what are the outcome for the second coin? It could also be head, right? And what are the other possible case, like where whenever the result of the first coin is head, in that case the result of the second coin can be tail, isn't it? So what we got, that one outcome is both, in both the coins we got head, and in another outcome we got one head and one tail. So in the first coin we got head, and then in the second coin we got tail. Now, is there any other combination possible? Okay, let us take a look. Yes. So there are other possible also, like combinations. Like first, in the first coin we got the result as tail, and in the second coin we may get the result as head. Similarly, in the first coin we got tail, and in the second coin also we got tail. So what are the combinations we are getting over here? One is, in both the coins we are getting head. In first coin we get head and second coin tail. In first coin tail and second coin head, and in both the coins tail. So we got four combinations. So that is head head, head tail head, and tail tail. So number of all possible outcomes are here is 4. Now what will happen when one coin is tossed together? So that means I toss the coin first, then again I toss the same coin. Okay. In the previous one, we have taken two coins tossed together, and whenever there is only one coin and we are tossing it two times. So there also we will get the same results. Like what, in the first time, the first coin can get head, and the second time it can get head also. So in this way we can get the four combinations that we have explained earlier also, like head head, head tail head, and tail tail. So in both the cases, like whenever we are tossing 8 coins together or one coin is tossed two times, we are getting the same outcomes. Now, what will happen when three coins are tossed together, or one coin is tossed three times? Thrice means three times. So, let us take a look at the table. The first coin, so if three coins are tossed together, then we will have first coin, second coin, and third coin. Or whenever one coin is tossed three times, then we have first time, second time, and third time. Right? So, in this way, the table has been drawn. Now let us take with the different outcomes. So let us first start with the all head. So head head head. So we will get in in all three cases head. Now let us introduce tail in the end. Okay. So that means in the third coin we will get tail, and in other two coins we will get head. Now we are going to shift the tail position. Okay. So now what we got, if we shift the tail position, so now tail will come in the middle position, and both the first and third coin will have the head, and the fourth outcome can be that first is tail and the other two, second and third, will be head. So whatever we got so far is 4 outcomes. So let us check if there are any more outcome possible or not. Okay. Now earlier we have started with all three as head. Now similarly we start with all three as tail and shift the position of head, and then similarly we will get another 4 outcomes. So let us take a look. So now in the second table, you can clearly see that first 3 coins we will get tail. Then at the end, we introduce the head. So tail, tail, and head. Then the third, we introduced tail, head, and again tail. So that means head we are shifting, right? We have introduced head at the end. Now we have shifted the head in the middle. And now we will shift the head in the beginning. So that fourth one will be head, tail, tail. So what are the all possible combinations we got? So now let us write the rule of getting all possible outcomes. So write possible outcomes of 2 coins 2 times. That is what we got earlier. That is head, 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 tail, head, and tail, tail. So first, whenever, if you can check, let me revisit it once again, that in the first column of the table, you can clearly see that in the first row, all three are head, right? Now from second and third and fourth, here we have 2 head and only 1 tail has been introduced, right? Similarly, if we take the second table, or first in the first row all are tail, from the second, third, and fourth, only 1 head is introduced in the table, right? So now if we write the possible outcomes of 2 coins 2 times, then we know that head, 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 tail, head, and tail, tail. Now according to the first table, now first what we are going to do, now first time we will put H means head as the result of the third coin. So if we earlier we already got 2 coins, if we toss 2 coins or 1 coin 2 times, we got the outcome as head, 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 tail, head, and tail, tail. Now if we introduce third coin, so third coin, what are the outcome? So third coin outcome will be head or tail. Now write head. In the first case, write head in all the combinations, and in the next set, we have to put the tail as the result of the third coin. So we got head, head, tail, tail, head, tail, and tail, tail. So these are the 8 outcomes. So in the first, what we have seen, in the first row, we have introduced, for the third coin, we have introduced head. And in the second row, for the third coin, we have introduced tail, right? So finally, we got total 8 outcomes. So the number of all possible outcomes is equal to 8. Now, we will discuss all possible outcomes of throwing 2 dice, game of chance, and playing cards. So when 2 dice are thrown together, so in dice, how many numbers are there? 6 numbers, right? So now if we are throwing 2 dice together, then what will happen? So consider the color of the first die as red and the second die as white. So this will be easier for us to understand. On first die, we can get 1, and the second die we can also get 1. So that is the first option. So we have marked the color red and white. So the combination of this, whatever the value we got, that is 1, 1. Now in the first die, we got 1, and the second die we got 2. Then what is the outcome? That is 1, 2. So in this way, first die as 1 and second die as 3. We got 1, 3. Then we will get 1, 4, 1, 5, and finally 1, 6. Now, similarly, now we will consider the first die as 2 and second die can be any value from 1 to 6. So what are the possible outcomes? That is 2-1, 2-2, 2-3, 2-4, 2-5, 2-6. In this way, first die we can consider as 3 and the second die can be between 1 to 6. So we will get 3-1, 3-2, 3-3, 3-4, 3-5, 3-6. Then we will get 4-1, 4-2, 4-3, 4-4, 4-5, 4-6. Then comes 5-1, 5-2, 5-3, 5-4, 5-5, 5-6. And at the end, if we consider the first die as 6, then it will be 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. So if you count, how many possible combinations of outcomes here? So in the first row 6 and there are total 6 rows. So the total outcome is 6 into 6, that is 36. So number of possible outcomes here is 36. So in this experiment, the possible outcome has to be written as seen here, that is 6 outcomes in every row. So we have already got that 6 outcomes in every row. Now for coin and dice to know the total number of outcomes, we can remember as follows. Okay, so for total number of outcomes in one coin, we already got 2, that is head or tail. Similarly, for total number of outcomes for 2 coins, it will be, we already got 4, that is 2 into 2. So for the one for the first outcome, first coin, and for second is the outcome of the second coin. Now, similarly, total number of outcomes in 3 coins will be 2 into 2 into 2, that is equal to 8. So, first 2 is for the first outcome of the first coin, second 2 is for the outcome of the second coin, and the third 2 is for the outcome of the third coin. So, similarly, the total number of outcomes in one die equal to 6, and total number of outcomes in 2 dice will be 6 into 6. So, first 6 is the first die, outcome of the first die, and second 6 is the outcome of the second die. Okay, now coming to the game of chance. So when we spin this one, so there are 8 numbers 1, 2, 3, 4, 5, 6, 7, 8. Now there is an arrowhead given. Now whenever we spin this head board, so it can happen that the arrow will point to 4. So any of the number, like the arrow can point to 1 or 2 or 3 or any of the number between 1 to 8. So on whichever number the arrow points, that number is taken as the outcome of that experiment. So all possible outcomes here are 1, 2, 3, 4, 5, 6, 7 and 8. So the number of all possible outcomes is equal to 8. So total 8 numbers. Now we will learn about playing card video, event and finding the probability of an event. So what is event? Event is the set of favorable outcomes. So we will go into deeper into this. What do we mean by favorable outcomes? So favorable outcome means something that you wish should happen or should not happen. So let us take one example. So let us assume a situation we are watching an India versus Australia match, and one ball is remaining and 5 runs are required to win. Okay, so maybe you are watching the game of the India versus Australia match. Now, so what do we wish to should happen? Okay, so obviously we want that India should win the game, right? So to win the game, what India needs to do, because only one ball is remaining and 5 runs are required, right? So either India should hit a 6 and win the match. So if India in one ball give a 6, hit a 6, then India will win the match. Or it can happen that India should hit a 4 and draw the match, because 5 runs are required means to win the game, 5 runs are required means if India has drawn hit a 4, then the match will be drawn. So otherwise, in any case, if India will hit 6, then then India will win the game. If India will hit a 4, then there will be a draw in the match. In other cases, like below 4, India will lose the game. Okay. So here, what is the favorable conditions for India to win? That is either draw the game or win the game. So, but what are the possible outcomes? So, it can happen that it will lose the game or win or draw. So, these are the three: win, lose, and draw. These are the three possible outcomes. So, any of these three could happen, right? So events are denoted by, normally whenever we call the event, so events are denoted by the capital letters. So here let us take A be the event, then we will consider that A be the event that India will win. So India will win means A equal to win, and there can be another event B such that the India doesn't lose. So doesn't lose means if India wins, then he has to score 6 runs. In one ball, he has to score 6 runs. Or if India doesn't lose, means that that could be a draw also, right? So doesn't lose means there are two possible cases, two possible outcomes. Either it can be draw or it can be win. So in both the cases, India doesn't lose, right? So, so I hope now this is clear, right? So whenever we are calling about the event, so event means the favorable outcomes. So here the favorable outcomes is, one outcome can be like India will win. So in that case, draw or lose, if anyhow these are the outcomes, then India will not win. So the only criteria for winning will be win. If India doesn't lose means there could be two outcomes, that it could be draw or it could be win. So in both the cases, it will be India will not lose. So we will represent with the event. You can name it with any alphabet. So, but that should be represent with the capital letters. Okay. Now, probability of an event. What should be the formula? The probability of any event will be the number of outcomes favorable to E divided by the total number of possible outcomes of the experiment. So, the whatever event we are asking, so for that event, what are the possible outcomes which is favorable to that event divided by all your possible outcomes. So, if I take the previous example over here, so in this case, if I ask you what is the probability of for India to win, then what will be the answer? So it can be represented at PA equal to win by all possible outcomes, that is 3. So there is only one chance of winning, so that will be 1 by 3. If I ask you, okay, what is the probability of India doesn't lose? So there are two favorable outcomes. That is, one is win, another one is draw. So 2 by total number of outcomes is, all possible outcomes is 3. Then it will be 2 by 3. So here P stands for probability and bracket stands for of, and E is the event. So event is denoted by capital letter. So this is the formula for the probability of finding an event. Now we will take a look of different types of events. So different types of events like rolling of a die. So in this case, all the possible outcomes are 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes. So if E is the event that a number less than 7 comma. Okay. So number less than 7. So number less than 7 can be any number between 1 to 6. Right? So if I ask you that what is the favorable outcome in this case? So in this case, favorable outcome is all 6 numbers like 1, 2, 3, 4, 5, 6, right? Because in dice, the number starts from 1 to 6 and the number less than 7. So it could be any number between 1 to 6. So the favorable outcome to this event is 1, 2, 3, 4, 5, 6. So all possible outcomes are present in an event. Then such an event is called a sure or certain event. So in this case, we can clearly see that favorable outcome is also 6 and all possible outcome is also 6. So in this case, this type of event is called sure or certain event, because we can clearly say that whenever we are, if I ask you what is the probability of getting a number less than 7 when we roll a dice, so the probability is always 1, because in this case 1, 2, 3, 4, 5, 6. All these 6 numbers are less than 7. So, this is a sure, like obviously the event will occur, right? So, that's why it is called sure or certain event. So, that is P probability of E equal to 6 by 6, that is equal to 1. So, what we got is probability of sure or certain event is always equal to 1. Now, rolling of a die, all possible outcomes 1, 2, 3, 4, 5, 6. Now, let us take an event F. F is the event of getting multiple of 4. So here what are the multiples of 4? Multiples of 4 means 4 multiplied by 1, 4, 4 multiplied by 2, 8, 4 multiplied by 3, 12. So 4, 8, 12. These are the multiples of 4. So now, out of these possible outcomes, what are the multiples of 4 over here? So that should be the favorable outcomes to F. So only 4, because we know that multiples of 4 are 4, 8 and 12, but 8 and 12 is not there. So only favorable outcome here is 4. So only one outcome is present in an event. Then such an event is called elementary event. Okay. So if there is only one outcome, then that type of event is called a elementary event. So in this case, PF will be 1 by 6. So that is a favorable outcome divided by all possible outcomes. So A is an event of getting 1. Like if I'm asking that what is the probability of getting an 1 when we roll a die. So only one possible outcome for that is favorable for this. So 1 divided by the total number of outcome is 6. So that is 1 by 6. So this is called elementary event. Like B is, and similarly B is an event of getting 2. So 2 is there only one time, right? So that is also 1 by 6. Similarly, if we ask getting 3, so 3 is there only 1, so 1 by 6. Similarly, getting 4 will also be 1 by 6. 5 is also 1 by 6. And getting 6 is also 1 by 6. So here, keep it in mind that getting 6 means not, we have to count the number. Okay, not the actual number, right? So getting 6, what is the possible outcome? Only one outcome, right? So out of total number of outcome, that is 6. So 1 by 6. So now we got getting 1 is 1 by 6, getting 2 is 1 by 6. So if we add all these probabilities, then what we got 1 by 6 plus, so 1 by 6 we are adding 6 times. So that is equal to 6 by 6. So finally we got that is 1. So what we got that whenever we are adding all the probabilities, then we will get 1 over here. So sum of probabilities of all elementary events of an experiment will give you 1. So elementary event, we are already explained that whenever there is only one outcome present in an event. So, but if we add all these elementary events, then the probability will always be 1. Now let us take one event G of getting number greater than 8. So, do you think it is possible? Greater than 8 means 9, 10. So, is there any number 9, 10, 11, 12 greater than 8 in the dice? No, there is only 1 to 6. So, getting 8 is never possible, right? So, the number of favorable outcomes to G here is 0. So, no outcome is favorable to an event, then such event is called an impossible event. So, impossible means which cannot occur, right? So, getting more than 8, even getting 8 is also not possible, or more than 8 is also not possible when you roll a dice, because there is only 6, 1 to 6 we can get. Beyond that, we will not get. So, this is called an impossible event. So, P of G is 0 by 6 because number of favorable outcomes is 0. So, 0 by 6 is equal to 0. So, probability of any impossible event is always 0. Now, let us consider X is an event of getting odd number when we roll a dice. So, odd number means, what do you mean by odd number? So, what is the favorable to X over here? So, odd means 1, 3, 5. These are the odd numbers. So, the favorable outcomes to X is 1, 3 and 5. So, here, and if I tell that Y is an event of getting even number. So, even number here is 2, 4 and 6. So the favorable outcomes of 2 is y equal to 2, 4, 6. So outcome of X and Y are not same, and together their outcomes gives all possible outcomes of the experiment. So you can clearly see that for X outcomes is 1, 3, 5, and for Y outcome we got 2, 4, 6. But whenever we are combining these two, they will give you all possible outcomes, but individually they are not giving the same outcomes, right? So hence, that's why this X and Y are said to be complementary events. So we will not get any number that is favorable to X in the Y. So that's why X is called a complementary of Y, and similarly Y is called complementary of X. So, but whenever we combine, we will get all the possible outcomes. So Px here is 3 by 6, that is favorable outcome is, total number of outcome is 3, so 3 by 6, and similarly Py is equal to, so if I simplify, that will be 1 by 2, and Py is equal to also 3 by 6, that is equal to 1 by 2. Now if we add this 1 by 2 plus 1 by 2, we will again get 1. So here we can say that Px, so complementary event is also called as, so if I consider that Y is opposite of X, so we can also consider it as not X. So Px plus P not X equal to 1, or we can also say that Py plus P not Y equal to 1. So that means sum of probabilities of complementary events is always equal to 1. So Px, so that means occurring an event and not occurring an event, if we combine, then if we add, we will always get 1. So now let us take some note, like probability of impossible event is always 0. Probability of certain event is always 1. Probability of any event lies between 0 and 1. So it will always lies between 0 and 1. And probability of any event cannot be negative, or it cannot be greater than 1. So the minimum value can be 0 and maximum value can be 1. So there is no chance of getting negative or getting more than 1. Now we will solve some objective questions based on different types of events and equally likely outcomes. Okay, so now let us take some questions. Complete the following statement. Probability of an event plus probability of the event not E. So that is complement of E. So you already learned that probability of an event plus the complement of that event is always equal to 1. The probability of an event that cannot happen. So that cannot happen means that is impossible, right? Impossible event. So the probability of that type of event is 0, and such an event is called impossible event. The probability of an event that is certain to happen. Certain means which is obvious. Like that is a certain event. So that the probability is always 1, and such an event is called certain or sure event. The sum of the probabilities of all elementary events of an experiment. What is elementary event? Elementary event is where the favorable outcome is 1, always 1. So, if we add all the probabilities of all elementary event, we will always get the value as 1. The probability of an event is greater than or equal to and less than or equal to. So, you already know that the probability, the range is always between 0 to 1. So, the probability can be between or greater than or equal to 0 or lesser than or equal to 1. Now, which of the following experiments have equally likely outcomes? Explain. A driver attempts to start a car. The car start or does not start. Let us read the all the different type of experiment, and we have to say whether it is equally likely outcome or not. A player attempts to shoot a basketball. She or he shoots or misses the shot. A trial is made to answer a true false question. The answer is right or wrong. A baby is born. It is a boy or a girl. Okay. So let us take the first question. A driver attempts to start a car. The car starts or does not start. So this statement is not, we can say it's not complete because we don't know the condition of the car, right? Also, how much confident the driver was. So, since we don't know anything about the car or the driver, so to say for an incomplete statement whether it has equally likely outcome is not possible. So, equally likely means outcome is only possible if we know what are the possible outcomes. So, in this case, we don't know whether we had, because here we don't know what is the condition of the car or about the driver. So here there is no chances of equally likely outcomes. So this experiment does not have equally likely outcomes. Now let us take a look at the second problem. A player attempts to shoot a basketball. She or he shoots or misses the shot. So this statement is also incomplete because we don't know the ability of the player, like whether the player is a new learner or she's an expert, he or she is an expert. So we don't know the ability of the player, right? So this experiment, if he's a new learner, then there is a chances of misses the shot is very likely. If he's an expert, then the chances of shooting the basketball is very equally likely. Like, so here it depends on the ability of the player, so that's why we can't tell that this experiment does not have equally likely outcomes. A trial is made to answer a true false question. The answer is right or wrong. So whenever there is a answer of true false question, so answer to any true false question is either true or false, right? So that is either right or wrong. So this experiment, it has equally likely outcomes. Now the fourth question, a baby is born. It is a boy or a girl. So whenever a baby is born, so it has to be either boy or a girl. So there is no other combination, right? So that means this experiment has equally likely outcomes. So what we got, that question number 3 and 4, they have the equally likely outcomes. Which of the following cannot be the probability of an event? 2 by 3 minus 1 by 0.5, 15%, 0.7. So we know that the probability of any event is always between 0 and 1. So 2 by 3, if we check, so 2 by 3 that lies between 0 and 1, but it cannot be less than 0 or greater than 1, right? So minus, so less than 0 is minus. So minus is never possible, right? So that's why minus 1.5 is cannot be the probability here. 15% means 15 by 100. So that is also between 0 to 1. 0.7 means 7 by 10. That is also between 0 to 1. So probability of an event can never be negative. So this B will be the answer. Now next question. If PE, that is probability of event E, is equal to 0.05, then what is the probability of not E? So already we know that there is a relation between the probability of event E and the probability of not E, that is the complement of E, right? So that if we sum up, it will always give you 1. So probability of E plus probability of not E. So we will just put a bar on top of E. That is equal to 1. So now probability of E is equal to not E equal to 1 minus probability of E. So if we subtract, so that is equal to 1 minus 0.05, which is coming 0.95. So the probability of not E is 0.95. So thanks for watching this video. Please like, comment and subscribe to my channel. And please press the bell icon for the subscription. And in the next, so today we have discussed something about, we will explain, we have already explained the concept of the probability. We learned about different concept of probability, different types of event. So in the upcoming videos, you will get more about the probability problems, and we will learn more about different type of probability problems. So please keep watching my videos, and you will get more updated content on the probability and other topics as well. Thank you.